Thank you very much. These are actually two contemporary pictures of the ocean. The one on the left is a completely protected, very large marine protected area, and the right side isn't. What I'm going to talk about essentially today is that people in my profession often like to talk about, let's do more to find out about it. And I'm all for that. I've spent my life doing or trying to do exactly that. What I'm going to argue is that actually we know enough science to know what to do. It becomes a political, sociological question than it is a scientific question. We only know what 1% of what there is to know, or so on, but we know enough, as we've heard in 2 lectures so far, what the problem is. We also know what the causes of the problem are. It is how to address them that is important. And it's becoming clear that so far we have not been able to fix it. CO2 increase in the atmosphere is actually rising. It's not as though we have begun to get a grip on it, despite huge amounts of attention on this particular issue. Why not? I'm going to address 3 particular possibilities here, which add into the whole story. Firstly, the population density. This is a thing which is very sort of controversial in a lot of countries, and it is something which I have been attacked over a lot of times, because I've said there are too many people trying to get too much resources. I've been called, as a result, a people killer, and things like that. Now, when I say something like that, there are too many people. There was a meeting I was at which was on small islands, which was about the sustainability of small islands. And it was a plenary, and I just started by saying, do we know how many people would be sustainable on an island like this? You're a people killer. Well, I wasn't suggesting everybody be castrated before they left the auditorium. Promise. I was just asking a question, because I think that as a scientist, if you cannot discuss... There you are. Someone doesn't like me talking about it. Yeah. If you cannot even discuss one of the terms in the equation, you can't really solve the equation. So let's at least keep an open mind and talk about it. Maybe it isn't a problem. The other one is human laws. We make lots of laws, lots of legislation, both regional, national, maybe multinational, like the EU and UN, and so on, like that. But sometimes they conflict with human laws, vaguely though we might understand them only. And when they conflict, in few important instances I'll talk about, they won't work. The third one is I'm going to touch on our history and why it is we've got into such a situation that although scientifically we know what the problem is, in a social problem, sort of situation, we cannot, as things are at the moment, do anything about it. If you want proof of that, we are not doing anything about it, but we all know that something must be done. 2 graphs here of human population per length of coastline. It's not surprising to see that the longer the coastline, the more people there are. But let's say we do a graph of the density of people on a coastline, for the coastline of the country, and the slope reverses itself. This is arable land only, and that's because places like Greenland, you know, it's 3/4 ice, and it's not land as far as humans are concerned. They can't use it. Or maybe a desert country which has a big internal center of desert. The islands on the left at the top there are the city-states, Singapore and so on like that. It's not surprising they are extremely high on the chart, but the industrialized ones of those have their ecological footprint far outside their own land area and EEZ area, or territorial seas. Some of them are fishing all around the world. So at the meeting of small islands, which I was talking about earlier, these are the ones on the left with higher than average densities of people per a distance of shoreline. the bottom line of both of these, put these glasses on, is the compliance with the UN Code of Conduct. You see, we all know what we should do. We all know we got to live nicely and hug people and so on like that. But so we have a code of conduct. It's no surprise, but this puts it in a graphical form, that the number of the development of the country has a correlation with the compliance with the code of conduct. But the graph on the right shows an unfortunate thing that, so, okay, the reverse of that, on the graph on the left, the poorer the country, the less developed it is, if you like, the less it will comply. But those are the countries, from the right graph, which have the highest amount of biodiversity. So you can see the impacts on biodiversity are very much affected by the poorer countries that are complying the least. It's kind of obvious. I hope nothing in what I'm going to say this afternoon is new to you. It shouldn't be, not with an audience like this. But it is a surprise how a lot of people haven't kind of worked that out. I had the privilege of meeting, well, they were in my department, one of them, two people who were the science fiction advisors to people such as Terry Pratchett. Their job was to show, this isn't really possible, Terry, do it this way, and that sort of thing. They wrote an article for the journal I edit, and in it they talked about whether it was the rich countries or the poor countries that were causing all the harm. This is also fraught with politics and political forms of correctness. They came out with the answer that all things considered, that one person is equal half a car. Now, if you heard that by a decade's time there'd be 1 billion more cars at present-day efficiencies on the roads, you should be horrified. I'm sure you would be. But that's the same as 2 billion people that we're projected to get. It's all very well pointing a finger at the affluent and the profligate countries, and I do. But also, we've got to realize that it is the poorer countries which are multiplying faster. Some countries that I've worked in, where people are dying all over the place, and I'm not exaggerating, have a population doubling time of only 10 years. And this is fairly new. Man-made laws or biological laws? I'm going to come back to that. Every country that has any rules about fisheries and fishing probably says, I don't know any that haven't, you can tell me if there are, says that it's okay to catch the big fish, but you should throw the small ones back. That's contrary to biological law. A 10-kilo female, the big fat mama, lays 1 million eggs, or 2 million eggs a year, maybe. The same biomass, the same weight, made up of 10 smaller fish, lay an infinitesimally much smaller number of eggs. What we should do, what every fisheries rule should do, is say fishermen have to throw back the big ones and keep the small ones. Okay, if you were to catch all the small ones, there'd be no big ones, but you won't catch all of them. But you see what I mean. Market forces are such that a big fish per kilo gets you more money as well per small fish. So here is a case where biological law, I use law rather loosely, is exactly opposite to every man-made fisheries law that I know about. And tell me if I have missed some. Why might this be important? If you ask people what people die of in the poorer countries of the world, they are going to list you malaria and whooping cough, whatever it is like that. But these are two graphs of only 5 years apart, showing that over 50%, over half of the of the mortality of humans under 5 years old is because there are resource shortages, because they're hungry, because there aren't enough resources left to feed them. It weakens them. I've had a lot of those diseases, a lot of us have in here. But being young and fit, we survive it. If we were malnourished, we wouldn't. These are 5 years apart. I have not been able to find information to see if things are improving on more recently than that. The figures over this 5 years have not been changed. These were FAO and people, and this was in the Lancet. With extremely reputable results, I would think. So here we have, it's difficult to tell how many people are dying in the countries concerned. They don't have paper. Some do, a lot don't. I have actually walked to field sites past people who recently died. We don't necessarily realize that in the wealthy countries, just how poor it is. We see the graphs also, as we have done earlier, and I did, of the population increase. The population increase is actually, the gross population increase is actually substantially greater. But the population mortality is also increasing, so it is the net that we see. If we say there's going to be 1 billion more people, that is net. There might be 1.5 billion more, but an increase of however many in the mortality, and the net is what you actually see measured. And that's rather salutary. So really, and in areas which I've worked, and I'm sure some of the people here have worked, there is a famine going on, and this one shows the particularly sad example of under fives. It's never called a famine. If you look up the learned journal Wikipedia, you will see examples of a famine, a rather morbid site, but very informative, and you'll see these are estimated deaths over particular times. Now, I suggest that a famine is defined as that because it might have a political or an easily identifiable cause, and perhaps because it has a stop date and a start date. That was a famine in Biafra, civil war. Easily explained. But I put to you that right now there is a continuous ongoing famine which is greater than any of those you see down here. Why has this arisen was the third question. Well, it seems to me to lie behind the idea of the nation-state. To end the 30 Years' War, we had the Treaties of Westphalia, a European sort of arrangement, whereby before that, somebody doesn't agree with me. Before that, a plot of land, a piece of land, a few thousand hectares of land, was owned or influenced by a variety of people, by the country, sure, by the wealthy duke, just as importantly, by that particular church, just as importantly. And the poor people there were made even poorer because they had to pay duties, tithes and taxes to all three, probably. And a lot of the battles and the wars in the past there were caused by who controls that bit of land. Read into that, who controls what resources, who controls what food, if you like. And these treaties established the supremacy of the state, pretty much for the first time in a concrete, even codified and written way, which said about the church, well, okay, you're very important, but you don't run this particular place, which we will now call a country. I'm simplifying it a lot, but that, and they were given powers and attributes. You have the sovereignty within it. What you do is your business. You govern it how you want. The church outside can't. Smaller states would ally themselves to the big ones. Quite obviously, we see that now all the time, for example. So they're not totally independent. A subservient small state would always be not entirely independent, but it is. It has a seat on the UN, but it's maybe not as important as some of the other big hitters. I want to move away from this just to talk about three different things which are affecting how we govern the planet. One, the Black Swan theory. The Black Swan theory is so called because everybody knew all swans were white. It was how a swan was defined. It had a long neck, but so do other birds. A flamingo does, and that can be pink. And that was the law. Not the law, that was the idea. Until people went to Australia, Western Australia, and found that some were black. So, read the last one first. So this is a disproportionate, so that blew that theory out of the water. So that's really the sort of, if you like, the disproportionate role of a high-profile, hard to predict or impossible to predict, and rare event, beyond normal expectations. The best example of this, I think, is the bank failures of a few years ago. They're too big to fail. They can't possibly. When they did, ouch, then it hit everybody quite hard. And the psychology of people, I think, is such that you may know that there might be a pink swan somewhere, but no, let's assume as though they're not. It can't happen. But someone might go somewhere and find pink swans. That's the black swan theory, and on the animal metaphor, one you've all heard of, I'm sure, which is the butterfly effect, which is how a small event can have larger consequences further down the line. And the Lorenz idea was if the flap of a butterfly's wings in Brazil sets off a tornado in the USA. This is deterministic, and unlike the first one, which we think or suspect can't really be modeled, this one can be. But it's terribly difficult to do so. There are too many variables, and we don't even know what half the variables are. We must know what all the variables are to be able to predict this. You can't solve any problem if you don't discuss some of them either. And unlike the black swans, they are, in theory, we think, with our present understanding, entirely predictable, at least in principle, if only we knew all about it. My earlier remarks are we know enough of the science already. I'm a scientist. I spent my life doing that. I want to always find out more, and I think everyone should. Don't misunderstand that as saying we can stop doing the science now. I very, very much hope I didn't give that impression. We've got to find out, for a start, what the starting conditions are, and we don't know those. One more principle, and there are bound to be better mathematicians in here than I am, but power laws. They're called laws, are they? Well, they might be, as far as I know. And it's a curve. It's a family of curves, and the best example, maybe, are earthquakes. There are very, very few extremely severe ones. More intermediate ones, and an awful lot of small ones. There are some every day, every hour, but they're too small to sort of worry about. The power laws fit an awful lot of different sort of observations, geological, biological, sociological. Frequencies of words in a book. The, in English, books, is by far the most abundant. Frequencies of family names. Some of you have a common name, some of you have a very rare name. Let's get biological. Frequencies of species richness in a clade, and frequencies of different species in an ecosystem. If you plot the number of people in towns, that follows power laws, and the visits to websites. Those people who, there's another one here, like the number of your friends on Facebook. Now, if you are Lady Gaga, you would have 50 million intimate followers. But if you're a very sad sort of person like me, I've got 2. And those are my children who live in Australia at the moment. So that follows a power law, let's call it. Think this through to nations, to the nation state which we formed. Some are very wealthy, an awful lot more are poor. That follows a power law. Just take people within any one country or in the world. A few people are billionaires, an awful lot of poor people are too poor even to have currency. Right? They fit that law. Now, what does that mean? Does it mean that with all the attempts that agencies do all around the world to equalize wealth and poverty, is it possible? Let's hope it isn't a law. There are lots of quirks around that, but I leave that thought with you, and it isn't a very, like an awfully comfortable law. We are increasing the rate of production of CO2, increasing the rate, I believe, in which it is being absorbed into the ocean, changing the pH and this sort of thing. Now, physics says it can't go on forever and ever, but within our lifetimes, and this is another thing, we tend to think of in our lifetimes, not in terms of the planet lifetime. When it comes to coral reefs, which is something I do research on, we know from past extinction events and from past events where reefs stopped being made for a while, it is now thought, because the acidification of the oceans dropped to a certain amount so that organisms can simply not calcify. That takes 4, 5, 600,000 years to recover. These numbers, these lengths of time, are longer than humanity has been around after evolving into Homo sapiens. I don't believe many of us can really think about what they are, and I don't think a politician who thinks in a cycle perhaps of 5 years can really understand it either. People do say in governments, for example, well, we won't do this and that because we haven't got all the evidence in. I say they're procrastinating. We know enough already. We can know more, we're not arguing that, but we know enough already. And I think we have now reached a point where we have got to call their bluff, if you like, say, no, actually, sir, always say sir, it gets you out of a lot of trouble. We do know enough, and you have no excuses not to act a bit more. What can we do? We can form committees. This is the horrendogram formed by Britain to manage marine protected areas before we even had any. And slightly later on, when we were thinking about having them, it had grown like this. They grow. They evolve too, usually by multiplying. Now, marine spatial planning is one method we have. We've already messed up a lot. We already do zone the oceans in an ad hoc way. Not in the best way, not in the optimum way. It needs a multinational approach. The Philippines, if you fly into the Philippines, you will pass over miles and miles of fish farms. It's already zoned. It might not have been the best place to zone, but marine spatial planning is to say, okay, we're going to sacrifice this area, the fish farms. And one thing is, at the other end of it, I go back to this, marine protected areas. It is not accurate to say we are managing the oceans, we should try to manage the oceans. We cannot. That's conceit. That is hubris. We can't even manage single species in the oceans. What we can do is leave it alone. We can manage human impacts on the planet. People don't like to be called a human regulator. They much prefer to be called a marine protected area manager, don't they? But we can't do the second. We can manage human people. Leave it alone, and it'll recover. And examples in the Philippines, for example, and elsewhere have shown that if you leave an area alone for several years, only about 4 or 5, you get a 3- to 6-fold increase in the amount of protein it produces, in the amount of income it produces for the villagers who are catching the fish. What you do in the intervening sort of time, alternative livelihoods, is another matter. The Pew Foundation were behind a great deal of these marine protected areas. I had the good privilege and fortune to be behind the science of the Indian Ocean one, only one, large enough to affect things in a big way, rich enough to be worth protecting. There are none in the Caribbean, isn't that sad? And have a governance that can continue the protection, at least in principle. There's no good building one next to Dar es Salaam, for example, for obvious reasons. The people are starving, don't blame the people. At one end of marine spatial planning are these very large marine protected areas, which are increasing in number, I am very glad to say. In them, one program that has been around the world to about 50 sites and has been to Chagos in the Indian Ocean said it is by far the best, the richest, the most diverse, sorry, not the most diverse, the sort of highest in terms of biomass that they have seen. Chagos, for example, has set many world records. Biomass, through to anything you like. And IUCN are putting out a book very soon, it's a bit overdue, which is on the right here, on how to manage it. I think all excuses for politicians have come to an end. They have got to act. We know enough of the science to do it. I'll leave that there before I'm attacked. Thank you very much.